Okay, class, we proceed on fourth order Runge-Kutta classical Runge-Kutta method RK4. Consider an inertial problem of first order ordinary differential equation where we got the function is dy dx equal to fxy or yx0 equal to y0. So by using classical RK4 method, Runge-Kutta 4 method, the solution is given by this one. Is slightly lengthy than as before. So we have this equation. Okay, this is based on the question given, and then the second formula is to identify the y value. Okay, the letters or the next value of y. Okay, by adding yi plus 1/6 of the summation of k1 to k2 3 times k3 plus k4. So all these things, please do not afraid lah. Okay, you just key in on your calculator. Okay, in your calculator you might put like we have A, B, C, right? So A, maybe A, okay, plus K1 over 6, okay, multiply by okay, A plus, okay, maybe 1.6, okay, something like this, okay. This one maybe B. Okay, so you have to remember, or maybe this one X. X, so okay, this one X, this one A plus 2B, okay, plus 2C, and then plus D. Okay, so you have to remember that okay, maybe this one y. Okay, so easy lah, okay. Easy. Y plus 1 over 6, okay, multiply by A plus 2B plus 2C plus D. So you have to remember that A is equal to K1, B equal to K2, K3 and K4. Okay, so and then from your calculator, they will ask you what is the number of Y, what is the number of A, B, C and D. Then you can straightforward follow the number as given in the question. Okay, this is for formula number 2, and formula number 3 until 5, 3, 4, 5, 6. Okay, until 3, 4, 5, 6. Okay, so for K1 you just simply you just multiply with H. K2 you have to, all these things you have to put in your calculator. Okay, so K2 you have to put maybe H is fixed, right? So you just put 0.2 multiply by, okay, in this case based on the equation. So in this question, not yet. Okay, later on, any x value you have to add with h over 2. Any y value you have to add with k1 over 2. Same goes to k3 where the y plus k2 over 2. Okay, this one the different. This one is k1, this one is k2. And for k4, okay, h fx ki plus h and yi plus k3. Okay, k3. So this is continuous. So we go to example 8.5. Okay, the initial value problem where we have this kind of function. Okay, y prime is equal to 4e power of 0.8x, okay, minus 0.5y with this. Okay, in this case x equal to 0, y equal to 2. Okay, has a unique solution y4 Okay, this case x equal to 4, y equal to 75.339. Approximate the solution at x equal to 4 using fourth order classical Runge-Kutta method with step size h. So h is 1. Subsequently compute the percentage of relative error. So what we are going to do right now is first you have to construct this table first. Okay, you have to construct. If they are asking you about to identify the ODE by using RK4, you have to construct the table like this. Okay, start from iteration I, start from 0, 1, 2, 3 and something like that. And in order to determine, okay, the iteration size or the iteration point, okay, until when, so you have to put, okay, x, okay, based on this information. So in this case, they are asking you to iterate from x equal to 0 until x equal to 4 with the step size is 1. So the x is, okay, start from 0, 1, 2, 3, 8. X, okay, start from 0, 1, 2, 3 and 4. Okay, while the y, okay, start with when x equal to 0, y equal to 2, and when x equal to 4, y equal to 75.339, and this one you have to identify by yourself. Okay, solution. Okay, okay, this is the formula according to this one. Okay, 1, 2, 3, 4, 5, 6. Okay, so the function is 4 multiplied by e power of 0.8x minus 0.5y, where the k1, okay, you have to multiply by h, k1. So k1, you have to multiply the function fxy with the h. So you just multiply. Okay, in this case, okay, this one multiply by 1. So same. So fxy is same as k1 because of the h is 1. If the h value is 2 or 0.5, so we got different value of k1. So in this case, k1 is you just copy lah. Okay, you just substitute based on this equation. And then k2, k3 and k4 are based on the formula, whereby the x, okay, you have to add with h over 2, same. This one and this one is same, but this one you have to add the yi with the k1 for k2, but for k3 you have to add y with the k2. Okay, slightly same but not same. Okay, and for k4, okay, k4 value you have to add x with h and y with k3. Okay, and multiply with h. Okay, so that's it. Okay, start from this one is start from the 0 until 4, and then the initial value is 2 until 75.439, and okay, let's say k1. Okay, k1, all this value you have to multiply by h. H in this case is 1. So you guys know, okay, for a power of e power of 0.8 x, okay, right? Okay, so in this case x is 0, so you put this one. Okay, for e power of 0.8 multiplied by x is 0. Okay, because in this here Okay, x is 0, and then minus 0.5 y. Y is 2. Okay, y is 2. So you will get this number 3.0. And then same goes to K2. Okay, K2. Okay, for K2, how we are going to get this number 4.217 is based on this one. Okay, 4 multiplied by e power of 0.8. Okay, this is x, right? So x is 0, and then plus, okay, this plus h over 2. Okay, h is 1 over 2. Okay, okay, minus, okay, 0.5y. Okay, here 0.5y. So 0.5y. In this case, y, you have to plus k1 over 2. So k1, what is the number of k1? K1 is 3. So y1 is 2. So you have to put 2. Okay. In this case, okay, 2 plus 3 over 2. So you will get this number 4.217. Okay. Okay, for K3 also, okay, you just change the K1 to be K2. So what is the number of K2? K2 is 4.217. So you have to change this one to 4.217 to get this number. And for K4, okay, K4, you have to multiply H, okay, multiply by all this number when x plus h and y plus k3. So in this case 4e 0.1 x, okay, x. So any x you have to add with h. H is 1, so h is 1. So this is the h. Okay, and y you have to add with k3 value. K3 value is 3.913. So you have to replace with 3.913. Okay, that's it. So and then you will get this number. So how you are going to get this number? The y1 I plus 1, okay, this number. How we are going to get this number? 6.201 is based on this equation. Okay, this one. So you have to add y1 is 2, okay, case 2, okay, plus 1 over 6, okay, multiply by k1. What is the value of k1? K1 is 3, k2 is 4.2, k3 and k4. Okay, okay, so you have to add follow this formula in order to identify this value of the current, okay, upon the current of y, the value of y I plus 1. So in order to identify the percentage of relative error, okay, you have to minus, okay, minus the absolute error, the exact value. The exact value is 75.339 as given in here. So this is considered exact value. Exact value. So you are not going to calculate anymore lah. You just use this number or this value as your exact value, and then this one is exact value, and then minus with what you get here. Okay, in this case you have 75.439. Okay, this is the approximate. Okay, and then divided by the exact and multiply by 100%. So you will get this percentage 0.1327%. Okay class, thank you very much perhaps you enjoy and you know how to differentiate between each method in ODE. So for the next tutorial, for the next class, we will proceed on boundary value problem. Okay, so